We're going to look at quadratic patterns, but before we do that, we're just going to recap on linear patterns. Linear patterns is where you have a table of points, and if you plot those points on a graph, you'll end up with a straight line. So that's what you'll end up over here if you join the points together. So how do we know it's a linear equation or a linear pattern? What we're going to do is we're going to work out the first difference. So if you work out the first difference, that's the differences between these numbers. That works out to be plus 2 and plus 2 plus 2 each time we do that. So what that means is that if the first difference is the same, or what we call constant, we know it's going to be a linear pattern. We know that the equation will be on this form. That common difference that you have there means this goes up in 2 on the graph, which means that the gradient will be 2 over 1. Okay, so our equation will be y equals 2x. Now all we have to do is work out the c or the b in this equation. So we need to work out what we add. To do that, we could go back, and it would be where on the table that the x is 0. Going back by 2 means that we will end up with a 1 in there. So that will be 2x plus 1. Notice it's the same as the y-intercept that is sitting on our graph. You can do this by guessing and checking using the other points. What we're going to do now is we're going to look at quadratic patterns, and you'll see some similarities between what we've done. I've already set up this table so you can see what we're doing here. So we're looking at quadratic patterns. The equation will be a quadratic, which means it'll have an x squared, and it means that we'll end up with a parabola. Notice when you plot these points that are in the table that you actually get a curve, not a straight line. So you know it's not going to be a linear graph. So what do? You do the same thing. You do the first difference, and then you calculate those. I've done them here for you. The difference between 5 and 0 is 5. 12 and 5 is 7, 21 minus 12 is 9, and these ones here are 11 and 13. You notice that they're not the same, so therefore it's not a linear pattern. So what do? You go and do the second difference. So we're going to look at the second difference here. So we do the second difference. Whoopsies. Let's just use my pen. Okay, so we're going to do a second, oopsies, let's go back to where we were. Okay, so we're going to use the second difference here, and then we just calculate the difference between 5 and 7, which is our first difference, 7 and 9, and we get plus 2, 9 and 11, which is 2, and 11 and 13, which is 2. This means our second difference here is constant. If the second difference is constant, meaning it's the same value, then the relationship must be a quadratic. How do we get the equation? We use our graphics calculator. You all have graphics calculators, so we're going to do it on there. So what I have done is what you do is you go into menu, you go into the stats. Okay, when you go into the stats, what you do is I just go into there. Oopsies, let's exit out of there. I've preloaded these numbers, so I've put in 0, 1, 0, 2, 5 from my table 3, 12. You only need 3 points. You can put the whole lot in if you want to, but you only need 3 points. What you're going to do then, after you've entered them in, you graph 1, and you press calculate, and then you'll get these 3 dots or as many dots as you've put in, and what you want is you want the equation. So the equation here is x squared, so you select that, and what will happen is that you'll get a quadratic regression. It means that your equation is in this form, and these are your a, b, and c. Okay, let's do that for you. So we write down a equals, oopsies, let's just move that around. Okay, so y equals a, which is 1x squared. You can just leave the 1 off, plus 2x minus 3 in this case, and that's the equation to this quadratic pattern. This works for all quadratics, and it's just a matter of doing the table and figuring out what you've got.